Hello Honors Geometry students, welcome to day one of rotations. When we talk about a rotation is a transformation. So we've been talking about transformations. Previously we talked about reflections. So a rotation is a transformation in which a figure, so it could be a point, it could be a square, it could be any type of quadrilateral, it could be any type of polygon, it could be a heart as you see down below, but it's a transformation in which a figure is turned about a fixed point. So a transformation in which a figure is turned about a fixed point. So you can see here, if you scroll down to number 1, you'll see that there is a rotation of a heart. You'll see the heart's right here, and then it's rotated 90 degrees, and it's all rotated around point P, which in this case lies on the origin. So that is our point of rotation. And you see the arrows pointing this way, which means it's being rotated counterclockwise. When we talk about rotations, we talk about counterclockwise rotations, and then we talk about clockwise rotations. Just like with reflections, a rotation is an isometry. And remember that word isometry. An isometry means that distance is preserved. So when I rotate a heart, or when I rotate a figure, the distance, or the shape itself, the distance is preserved. Meaning this distance, or this length of this side of the heart, doesn't change when I rotate it counterclockwise. So for example, let's say I were to go over here, and I'm going to do my best to draw. I know it's kind of difficult here. So let's say I were to have an arrow. If I were to rotate this arrow clockwise, okay, 90 degrees, it would look like that. Then if I were to rotate that arrow 90 degrees, okay, now my new arrow would be right here. But notice that I'm staying around the origin, around my point of rotation. And if I were to rotate another 90 degrees clockwise, it would be right there. So when we talk about rotations, again, think of them in terms of clockwise rotations and counterclockwise rotations, and always around a point, around a fixed point. In these cases, we're rotating them around the origin. Okay, so let's go to the final few examples here on this rotations day 1. The directions say the diagonals of the regular octagon below form 8 congruent triangles. Use the diagram to complete the sentence. So the number 2 says it's a clockwise, or it wants us to do a clockwise rotation of 45 degrees. Notice that we have a 45-degree angle here. And now let's think back to chapter 6 when we talked about the word regular. Okay, well, this is a regular octagon, so that means all these sides are congruent. Okay, and all these corresponding angles are the same as well. So if this is 45 degrees right here, then all of these have to be 45. You could say 45, 45, 45, 45, 45, 45, and 45. So all of these angles right here are 45 degrees. So I'm always going to be rotating in increments of 45 degrees. And we're rotating around center point P. Now when it says a clockwise rotation of 45 degrees about P, okay, remember about means around P, maps. Remember that word maps just means moves. So it's a clockwise rotation of 45 degrees about P, moves A onto what point? So if I move A 45 degrees clockwise, I'm going to end up on point B. What if it says, the next one says a clockwise rotation of 90 degrees, again, about P, so around P, moves C onto what? Well, now I have to move C 90 degrees. Well, again, a 90-degree rotation is the same as two 45-degree rotations. So I'd go 45, 90. So that would move point C onto E. Alright, any questions? No? Okay. Alright, well, let's go on to number 4 then. Alright, so number 4 says a clockwise rotation of 180 degrees. So now we're moving at 180 degrees. About P maps what point onto F? So I want to know what point, if I rotate it 180 degrees, will I land on point F? Okay, well, a couple ways you could do this. You could just literally look right across and you'll see point B, or we could start at point F and rotate back 180 degrees and see where we end up. We'll notice we'll go 45, 45, that's 90. Alright, and then 135 and 180. So if we rotate point F 180 degrees backwards, we'll end up on point B. So if I rotate point B clockwise 180 degrees, I'll end up on point F, which is what number 4 is asking. Alright, number 5 says now we're going counterclockwise. A counterclockwise rotation of 90 degrees maps 90 degrees about P maps H onto what point? So now we're starting at point H. We're not going clockwise anymore, we're going counterclockwise. So that's, if I rotate H 90 degrees, again that's 2 45-degree rotations. I'm going to end up 1, 2 onto point F. Alright. Number 6 says a counterclockwise rotation of 45 degrees maps P, about P maps what onto E? Okay, so again we're moving counterclockwise, so we're going this way around the circle. And it wants to know what point, if I rotate it 45 degrees, will I end up on point E? Well, if we start at point E and we go backwards 45 degrees, we will end up on point F. So if I take point F here, and if I rotate it 45 degrees counterclockwise, I will end up on point E. And lastly, number 7 says a counterclockwise rotation of 135 degrees. So remember, 135 degrees is the same as 3 45-degree rotations. So a counterclockwise rotation of 135 degrees around P maps what onto A? Okay, so there's A. So it wants to know what point, if I rotate it 135 degrees, will I end up on point A? Well, notice if I start it, and I'm going counterclockwise. So again, if I start at point A and I go backwards 135 degrees, so that's 1, 2, 3, I'm going to end up here on point D. So if I take point D and I rotate it 135 degrees, 3 45-degree rotations, 1, 2, 3, counterclockwise, again we're still going this way, I will end up on point A. Alright, so that's it for part 1 of rotations. Part 2, make sure you watch part 2, that'll be a little bit more in-depth. And please see me or one of the other honors geometry teachers if you have any questions. Alright, have a good one.